Hello everyone, today I am going to discuss an array problem. We are given an array of words and a pattern, and we need to find all those words within this array that matches the pattern. And they have given one rule for pattern matching. A word matches the pattern if there exists a permutation of letters p, so that after replacing every letter x in the pattern with px we get the desired word. It is a bit confusing language and statements, so let me explain it with the help of an example. So we are given an input array of words and pattern, and we have to return a list of words that matches the pattern. We can solve this problem by following these two steps. First, we need to find the permutation grammar regex value, you can call it anything, for the given pattern, and we can store the permutation value of the pattern in some variable. The next step, we will iterate through each word in the words array, and we will compute the permutation value of each word using the same method we use for computing the permutation of our pattern. After calculating the permutation value of the current word, we will compare it with the permutation value of our pattern. If it matches, then we will add that word in our output list. Otherwise, we will move on to the next word. So let me explain this by running our algorithm on one example. Okay, so we are given a pattern ABB, and first we need to do step 1. We need to find the permutation value of this ABB. For finding the permutation value, we would need a couple of data structures. We would need hash map data structure, and we would need a string builder class, string builder object. String builder is a mutable sequence of characters, so let's call it S. This string builder object will store the permutation value of our pattern ABB. We will also need a variable index of type integer. Initially we will initialize this with 0 value. Okay, so now we will iterate through this ABB pattern from left to right, one character at a time. The first character is A. First we will check whether A is present in our hash map or not. If it is not present, then we will first increment the index by 1, and we will add the character as key and index as value in our hash map data structure. We will also append the index in our string builder object. We will move on to the next character, which is B. B is not present in the hash map, so we will again increment the index by 1, and we will add character B along with the index value in our hash map, and we will append the index in our string builder. Now the next character is B. B is already present in the hash map, so we will just append the index value in our string builder object. So this is the permutation value of our pattern. We will store it in a variable S. Okay, now we will move on to the next step, step 2. We will iterate through each words one by one. So let's look at the word ABC. ABC. Again, we will use the same technique for computing the permutation value of ABC, and let's store the permutation value in some variable B. Okay, so before computing the permutation value, we will clear this hash map data structure, and we will again set the index to 0. Okay, so we will iterate through from left to right. A, first character is A. A is not present in hash map, so we will increment the index by 1 and store A and index in our hash map, and we will append the index value in string builder object. Next is B. B is not present in hash map, so we will increment the index by 1, and we will store B and index in our hash map. We will also append index in our string builder object. Next character is C. C is again not present in our hash map, so we will increment the index by 1, and we will add C as key and index 3 as value in our hash map, and we will append the index in our string builder object. So now we are done with ABC string or word. So you can see that the permutation value of ABC does not match with the permutation value of our pattern. So we will skip this word, we will move on to the next word now. This will not be included in our output list. So we will again clear our hashmap data structure. Okay, and we will again initialize the index value of to 0. Before moving on to the next example, I would like to point out one optimization. Okay, suppose the permutation value of our pattern is 1, 2, 3, 3, 5, 6 of some pattern. Okay, and suppose in the step 2, when we compute the permutation value of some word, it comes out to be 1, 2, 4, 3, 5, 6. Clearly these two does not match, so we will not include that word. But the optimization which we can do is, we don't need to compute the permutation value for the word whole. Okay, so we just need to compute the permutation value till this point. At this point the 4 does not match with the 3. Okay, so we can just break out from the for loop, and we can move on to the next word because it would not match. So we can skip computing this 3, 5 and 6 value. This is one optimization which we can do. Okay, so now let's go back to our same problem and let's look at the permutation value for MEE. So MEE, and M is not present in our hash map, so we'll increment index by 1 and store M character along with the index value in our hash map, and we will append index in our string builder object. Next character is E is not present in our hash map, so we will again increment the index by 1 and store E in our hash map, and we will append the index in our string builder object. Next character is again E is present in our hash map, so we just gonna append the index value in our string builder object. So now we are done with MEE. So you can see that this matches with the permutation value of our pattern, so we will include MEE in our output list. Okay, now let me show this step 1 and step 2 in the code along with the optimization. Okay, so I have defined one find and replace pattern class. Inside this class I have defined two methods. One is static main method and another is where I am doing the actual computation. In the first main method, I am just instantiating the find and replace pattern class, and I am just calling find and replace pattern by passing two arguments, word array and the pattern. Inside this find and replace pattern method, I am first converting the pattern from string to the array of characters. Then I am initializing one array list. This is the array list which I am going to return, and in the next line I am initializing a map data structure. Then this is the first step which I am doing. The first step is computing the permutation value for this pattern. Okay, so I am just iterating through this pattern array character by character. I am just doing the same thing which I showed you in while explaining the algorithm. Okay, here I am just printing the permutation value. After this I am doing the second step. I am iterating through each word one by one, and first I am checking whether the word lengths are same or not. If they are not same, then I'm just skipping that word and moving on to the next word. Okay, so in the step 2 I also need to compute the permutation value of each word. So this is what I am doing here, and before this I am creating one variable isMatch and I'm setting it to true. This is the optimization which I was talking about. I'm just comparing the index value of the permutation and the permutation value of the given word. Okay, if they does not match, then I am just setting the isMatched value to false and I'm breaking out from here. I'm not moving ahead through this loop. Okay, and after this, if the isMatch is true, it means that the word matches with the pattern. So I am adding that word in my match word array list, and finally I am returning that array list. Let me run this program. So you can see that it has returned MEE and AQQ, which is our answer. Let me copy this solution and run it in this. I'm going to submit this solution and check whether it works or not. It will work. So you can see that it got accepted. We can do some optimization also, but I think it's fine. So that's all for this video. Thank you guys for watching this video. Bye.